So the first problem is for the AC network, which is shown in the figure, determine using mesh current analysis the mesh current I1 and I2, the current flowing in the capacitor, what is the current that is flowing through the capacitor, and active power which is delivered by the 100 volt AC source. So they have given the circuit like this, which means here the current flowing through this one is I1. This is I1 and this is I2. So according to the Kirchhoff's current law, this must be I1 minus I2. So I can write the mesh equation like this. 100 is equal to 5I1 minus J4 into I1 minus I2. So this I can write it as 5 minus J4 I1 plus J4 I2. So this is your first equation. And for the second equation, I can write, I can add this all these values. So if I add all these values, I will get 0. There is no voltage source and current source. So if I add this value, I will get 4 minus j I2, since it is a I2 mesh. And you can see this I2 direction and I1 direction are opposite. So if it is positive, this must be negative. So negative of minus J4, because J4 is between I1 and I2. I1. So this is your second equation. So I can write 4 JI1 4JI1 plus 4 minus J I2. This is your second equation. So now I can solve this one. I can solve like this. So I need to find the determinant value. What is determinant value? Determinant value is 5 minus J4. And 4J, then 4J, 4 minus J. So if I solve, I will get 5 minus J4 into 4 minus J, minus 4J square. So this I can write it as 5 into 4 is 20, minus 4 into 4J is 16J, J square. 4 minus J. 16J. Then this is minus 5J. And this one is plus minus 4. 20 minus 16J minus 5J plus of minus 4. Minus this becomes 16. 4 becomes 16. J square is minus 1. So it is, this is equal to 20 minus 4 is 16. So this is 32 minus 21 I. So what is del 1? Del 1 is equal to, so you see this one, you have to substitute 100 and 0 in the first column. So you have to substitute 100 and 0 in the first column for the del. 100 and 0, and rest you have to keep it same. So if I solve, you will get 100 into 4i. This is equal to 400 minus I. So what is the value of I1? I1 is equal to del 1 divided by del. So that is equal to 400 minus 100, minus 100i divided by 32 minus 21i. So this is equal to, if you solve this values, you will get, so you have to convert this 400 minus 100 I. So 400 minus 100i, if I write it in the polar form, it is 412.3 minus 14.036. And this one is 32 minus 21i is 38.275. Angle is minus 33.275. Okay. So these two get cancelled out. If I cancel it, the answer is 10.77, and this becomes minus 14.036 plus 33.275. So if I add, I will get 10.77. Angle is 19.275. Okay, so I will find out the value of I1. Likewise, to find the value of del I2, first you have to find the value of del 2. So del 2, I have to substitute this value 5 minus J4, 4J. So if I solve, you will get minus 400i. Okay, so what is I2? I2 is equal to del 2 divided by del. Sorry. So this is equal to 400 minus 90 degree divided by, what is del? Del is 38.275. This angle, if it goes up, it becomes 33.275. So if I solve 400 divided by 38.275 is 10.45. And 90 minus 90 minus plus 33.275 is minus 56.725. Okay.
Yeah, when gonna
So find out the value of they're asking about I1 and I2. We have find out the I1 and I2. What is the current that is flowing through the in the capacitor? So the current flowing through the capacitor is I1 minus I2. So current flowing through the capacitor is I1 minus I2. So what is I1? I1 is 10.77 angle 19.275 minus 10.45 angle minus 56.725. Okay, so 10.77 and 92.75, I can write it as I would convert this one into a rectangular form. Okay, so how to do this one? So you go to the calculator. So I'm not having the calculator right now, so I'm doing it in okay. So if we solve, convert this one into polar form, polar to rectangular form. This is 10.77, angle is 19.275. So you'll get 10.166 plus I 3.5. 3.58. Likewise, this if you convert this one, minus 56.725, so we get 5.733 minus 8.737 I. So to solve this, you will get the answer like this. Okay, so it will take time, so let me write the answer. Okay, so it may vary because I'm not using the calculator right now. Okay, so this is the current that is flowing through the capacitor. So next, what they're asking about active power delivered by the source. So the active power delivered by the sources, because the source you have having 100 volt, right? So active power delivered by the 100 volt source, right? So active power formula is this 100 into I1. What is I1? I1 is this is your I1, right? 10.77. 10.77 cos of this value. So V by I. So V by I is V is 0 and I value is 19.275. So you can write this one. Okay. This is minus 19.275. Okay. So cos of minus value is positive only. So if you solve, you will get answer as 1016.8. Okay. So since this will also change because I'm not using the calculator right now. Okay. So this is a power that is delivered by the source, and it is observed by the resistance, right? So you can see I have resistance at this one, the 5 ohm and 4 ohm resistor. For 5 ohm, I am having I1 as a current. For 4 ohm, I having I2 as the current. Okay, so I can write this is a power delivered, the power observed by the 5 ohm resistor. That is I1 square into 5, right? Next one is I2 plus by the 4 ohm resistance, right? That is I2 square into 4. So if we solve, what is I1 square? I1 square is 10.77 square into 5 plus 10 point I2 is 10.45. So 10.45 whole square into 4. So if you solve, you will get the same answer like 106.8 volts. So we calculate this. So 10.77 into 100 cos 18.275 into 10.77 106.62. Okay, and here it is 10.77 over 2 into 5. That's 479.96 plus 10.45 square into 4. That is 436.81. So if I add, I get 1016.47. So both the values are same. Okay. This is active power that is delivered by the source, and it is active power that is absorbed by this resistance. So this one of the element asked. Okay. So next, let's go for the another problem. So the question is, this is a diagram they are given. They are asked to find the voltage at the node at 1 and 2, and the current that is flowing through this inductance. Okay, and the current flowing through the 5 ohm resistance. Okay, and the magnitude of active power dissipated by the so they are asking about the power. Okay, so let's solve this problem. So since they are asking the voltage at the node, so let me take this one as V1 and V2. So the current direction is like this. So you can see all the current is flowing outward. So suppose if this is I1, I2 and I3, I can write all the current is going outward. I1, I2 plus I3 is equal to 0. So what is I? I is nothing but V by R. So it starts from V1 and it ends at 25. Okay, this is your V. Divide by resistance values 2. Okay, plus what is I2? I2 starts from V1 to 0, and resistance values here the impedance is minus J4. Okay, likewise this is V1 set. This is V1 minus V2 and divide by 5. Okay, that is equal to 0. So this I can write it as 0.5 V1. 1 by 2 is 0.5 minus 12.5. Okay. If I multiply J on both sides, I will get this becomes plus. Okay, so plus J 0.25. 1 by 4 is 0.25 V1 plus 1 by 5 is 0.2. 0.2 V1 minus 0.2 V2, that is equal to 0. So if I add this one, you will get 0.7 V1 plus J 0.25 V1 minus 0.2 V2, that is equal to 12.5. Okay. So 0.1 minus J 0.25 V1 minus 0.2 V2, that is equal to 12.5. So this is your first equation. Okay. So let's do it for the second one. Okay. So this is I4, I5 and I6. Okay, both the currents are going outward. So I can write I4 plus I5 plus I6, that is equal to 0. So what is I4? I4, this is I4, I5, I6. Okay. So I4 is equal to V2 minus V1, starts from V2 to V1 divided by 5 plus V2 divided by J4 plus V2 minus 25 90 degree divided by 2.5, that is equal to 0. Second. So if I solve, I will get, let's change the color, 0.2 V2 minus 0.2 V1 minus J 0.25 V2 plus 1 divided by 2.5 is 0.2 minus 0.1 plus 0.5, 0.4. 0.4 V2 minus 10 90 degree. Okay, that is equal to 0. So I can write minus 0.2 V1 again plus 0.6 minus J 0.25 V2, that is equal to 10 of 90 degree. So this is your second equation. Okay, so let's find the del value. So what is del? Del is equal to, for 0. This is 0.7 plus J 0.25 minus 0.2, and this one is minus 0.2, 0.6 minus J 0.25. So this I can write it in the polar form as 0.743 angle 19.65. This is minus 0.2 minus 0.2, and this one is 0.65, angle is minus 22.62. Okay, so if you solve, you multiply this one and you have to add this one. Okay, so if you do like that, you'll get 0.482, angle is minus 2.97, minus if I multiply this one, you will get 0.04. Okay, so if you solve, you will get 0.442 minus 2.97. So this is your del value. So we can solve this one. Okay, polar to rectangular form. This is 0.482, and this one is minus 0.4. So 2.97. Answer is this one is 0.481 minus J 0.025 minus 0.04. Okay. So if we solve, we will get 0.441 minus 0.025 and check. So if I convert rectangle to polar form, 0.441 and minus 0.025. So 0.417 minus 33.26. Okay, so what is del 1? Del 1 is equal to 12.5. Okay, 12.5 and this 10 of 90 degree. And this one is minus 0.2, 0.65, angle minus 22.62. Okay. So if you solve, you'll get This, if I multiply, I will get 8.125 minus 22.62 minus of 0.2, it becomes plus, so 2 of 90 degree. Okay. So if I convert, I will get 7.499. I do convert this one into a polar form, a rectangle form. I will get 3.126 I plus 2I. Okay. And so on solving, you will get 7.499 minus 1.126I. So this is equal to 7.583 and minus 8.539. Okay. So what is V1 now? V1 is equal to del 1 divided by del. Okay. So 7.583 minus 8.539 plus 2.9. What is my del? 3.24. Okay. This is 0.4417. So what is 7.583 divided by 0.4417? It is 17.16 and 8.539 3.24. So if I subtract, I will get minus 5.29. Okay. So if I convert polar to rectangle form, answer is 17.16 and this one is 5.29. You will get answer as 17.087 minus 1.582. Okay. So similar way, you have to find the value of del 2. Okay. So what is del 2 now? Del 2 is equal to this is 12.5 and this is 10 of 90 degree. What is del? Del is 0.743, 9.65 minus 0.2. This one again. So in solving, you will get 7.43 and 9.65 plus 2.5. So if you convert this one, you will get minus 2.498 plus I7 plus 2.5. So you will get 7i. So what is V2? V2 is equal to 7i divided by 0.422 minus 2.97. So 7 divided by 0.422 is 15.83. This is 90 degrees. So 90 plus 2.97 is 92.97. So the answer is minus 0.82 plus I 15.80. So this is your V. So what they are asking to find the value of the current flowing through the they are asking about the current flowing through J4 inductance. So you have to divide V2 by J4. Okay. So you have to divide V2 by J4. the current flowing through the inductance. Okay, so what is V2? V2 is 15.83 92.97 divided by J4. I can write it as 4 of 90. Okay, so if you solve, you get the answer as 3.95 or 2.97. This is approximately, I can write it as 4 of 3 degree. Okay, so next one is they're asking about current in a 5 ohm resistance. So this is V1 minus V2 divided by 5. Okay, so the current in the 5 ohm resistance is V1. What is V1? V1 is equal to so this is your V1, okay, 17.087 and 17.087 minus 1.582 okay, 17.087 minus 1.582 minus V2. V2 is 0.82 0.82 minus 15.80 divided by 5. Okay. So this is nothing but I2. If we solve, we get 17.9. Okay, and what does 15.8 that's 1.582. Can you get minus 17.32 35 divided by 5. Okay. So this is equal to minus 3.479 and there is 17.9 divided by 5 is 3.58. Okay. So if we convert the rectangle to polar form, means that it is not necessary. Okay. So next one is there's a current flowing through the next magnitude of active power dissipated in the 2.5 ohm resistor. So here the current is I need to find the current. Otherwise in cap. So if I want to find the current it is a power dissipated by the 2.5 volt resistor. So if you want to find the current, that is V2 minus 25 of 90 degree divided by 2.5 ohm resistor. This is your current. So current square into 2.5. Okay. So if you solve, this is nothing but 15.83 92.97, right? This is your V2. Okay, this is your V2. So V2 minus 25 of 90 degree divided by 2.5 whole square. Okay, into 2.5. So this 2.5 and 2.5 get cancelled out. So this polar form you have to convert into a rectangular form. So if you convert, you will get 0.82 minus 0.82 minus 9.2 I square divided by 2.5. Okay.
See it myself.
So if you solve this one into polar form, you will get this. So I'm going to, you should not take this angle. So 9.236 square is 85.3 divided by 2.5. So this is equal to 34.12. So if this is your answer. So since I am not using the calculator, the output may differ, but the procedure of this one is same.